Do you guys know? What do you mean find the answer? What do you mean? Okay, when you say find the solution, you're doing cyclic reasoning. You're using the word to define the word. You can't do that. If x plus 2 is equal to 5, that's an equation. Told you I literally would move you. Because it's not working with you there. Okay. Okay. If x plus 2 is 5, Grant, I'm going to tell you that x is equal to 2. Have I solved that correctly?
No, it's 4. No, it's 3.
How do you know it's 3?
Well, it could be negative.
No, that's how, guys, that's how to solve it. That's not telling me why that's wrong. I'm going to insist it's right.
Okay, cool.
Why do you say it's wrong?
Because it's not right.
How do you know it's wrong?
We'll plug it in.
Okay, Mariah's got it. You put it back in the equation, and Cole, if I put this back in the equation, what happens? 4 is not equal to 5. Grant, try to sit still, please. Try to sit still. If I put it back in here, it doesn't make a true sentence. Okay? Mariah, put that away. Okay. And what does it mean to solve an equation? You want to find the numbers, because there may be more than one, that make the sentence true. You might have to do distributive. Now, the process of trying to figure out what those numbers are is called solving. That's the process. But what does it mean to solve? It means to find the numbers. Is guess and check okay? Find numbers that make the sentence, oops, forgot the last word, true. We've done this before. Well, I don't know if you did this in your previous classes. That make the sentence true. You want me to put the word the there.
Question. Is the equal sign, like when they're both like equal, is that the little squiggly thing?
This is approximately equal to. These are equals. Okay. So my goal is to find numbers that make that true. Can I just, what number makes that true? 3. Now, if you really want to get particular about it, what makes this sentence true? 3. 3. 3 is equal to 3. It's obvious what makes that true. This may not be obvious what makes that true. In this case, it is kind of obvious. So the process of changing this equation to that is solving. That's the solving process. And guess what? Okay, Rachel? This equation and this equation are not the same. Grant, I think I'll have to send you down to the SBR room. I need you focused. Yes, you are. You're doing this. Yeah. That doesn't matter. Okay, you guys, it's important for you to realize this. When you go on and take more math, Lalo, that when you change this equation to look like this, they're not the same equation, but they have the same candidates to make these both true. But sometimes, like if I do this, now have you guys seen square roots, right? What's the opposite of square rooting? No. Squaring it, right? Which we're going to get to in this. I think we'll get to some of this. Now, when I do this, that's just x. It says x is equal to 9. Now, 9 makes this true, but is the square root of 9 equal to negative 3? Can't do square root of negative 9 either. If you put on your calculator, you'll always get a positive 3. Okay? You're not going to get that. So this is called an extra answer. It's extraneous solution. But we have to understand that this gives me numbers I can try in there to see if they make it true. If you know what it means to solve, then inequalities are so easy. Now, some of you said, well, this points a certain direction. I don't care. Let's put it in words. What is x? It's any number. Any number
Oh, no.
that's less than, you're right,
No.
or equal to 3. Now,
Are we doing this thing where you have to like make the error?
well, then why don't you just let me get there and we'll see. What numbers are less than? Give me some numbers. Lalo. 5 isn't smaller than 3. Negative 1, 2,
That way.
0. How about a fourth?
Zero even a number?
Yes. Can I list them all? I can't list them all because there are like a million of them. There's an infinite number of numbers. So what do, Grant? We draw a picture. That's what the line is. It's the numbers, those order pairs, that satisfy that relationship. You have a line on your graph, on your notes? And there's 3. Now please get your, and I put the numbers on there. No, did I put the numbers on there? Yep. So this is 4, this is 2. Now, I want numbers that are less than 3 or equal to 3. So what's the first number I'm going to count? 3. Now, I get to include it. Here's just a little trick, because there's a little bit more pencil mark here. That's going to be filled in, if you forget. Now, I want numbers smaller than 3. Well, I'm going to go to the left then. Now, some of you said, well, this points in the correct direction. What if I gave you this?
Can I go the other way?
No, it doesn't. It's the same inequality. Because this says 3 is bigger than all these numbers. Now, it's going to be one side or the other. Just find one that makes it true. Is 2 smaller than 3? And what if I do it this way? 3 is bigger than 2. That makes it true. Now, if you always have the x on the left, this will point in the correct direction. If you notice what happened when I flipped it. I put the x there and I put the 3 there. What happened to this guy? It switches. Okay, that was the first one. How about this one? I want numbers. You don't have to write it out, but if you have problems with it, write it out. That are what? Greater than -8. So here's my number line. There's my -8. What's to the right of it? -7, and this is -9. So I find the 8. Do I get to include -8? Do I get to include it? Does it have this extra little line? Nope. So I want numbers bigger than -8. -8 is not bigger than itself. Then I can test, what's the easiest number to test? How about 0? I love 0. It's the easiest one. Is 0 bigger than -8? Yes. That means everything on that side will make it true. So all I have to do is just test regions. Now I'm going to build on that probably even next year. I don't know if anymore this year, but for sure next year. Okay, Grant, how about that one? Now that's in the wrong order. Okay, Julian, what are we going to do with this one? Where's your boundary here? Where are we going to look at this? At 6. You always start here. Do I get to include it? It's less than. Okay, now you can try numbers. Let's try 0. Is 6 smaller than 0? No. So which way does it go? 0 is a number. No, it goes that way. 0 is right here. Is 0 smaller than 6? I'm sorry, is 6 smaller than 0? I said that wrong. No, I'd rather have $6 than $0. Well, let's try 7. Is 6 smaller than 7? Yeah. So then everything over here will make it work. One side or the other. That does not point in the right direction, because it's not written with the x first. So x, if I want to put the x here and the 6 there, I would have to do this. I prefer to rewrite it that way, honestly, because even I get confused. Now, we haven't done these, but what happens, yeah. Oh, we're going to subtract 3. Is that going to change the inequality symbol?
No, don't you just draw a line down it?
Well, this is x. What's 3 subtract 3? 0. then I still keep the inequality the same. But, you know, I want to make sure that that's right. Let's take 2 plus 3. Is that greater than or equal to negative 1? I'm just made up a problem, similar. So 5 is greater than or equal to, well, let's leave it 2 plus 3. What if I subtract 3 from both sides? 2 is greater than or equal to negative 4. Did that stay true? Yep. Yes. So adding or subtracting a number from both sides doesn't change it. Inequality stays the way it is, and then we graph it because I can't make a list of everything. It's impossible. What goes over here? Negative, nope, 3. Do I get to include negative 4? Henry, do I get to include negative 4? And I'm looking for numbers that are bigger than negative 4. Which way? To the right or to the left? Let's try 0. Is 0 bigger than negative 4? Yes. That is. That's it. Mariah? No.
You want to hear my funny joke?
No.
It's pretty funny.
Nope. Okay. Mariah, I'm going to send you out then. We're not doing that right now. We're doing our work. Now, let's do this. Yeah, that's okay. That'll work. Okay. Rachel, I need you here. Rachel, I'm teaching you right now. Then if you don't get it, no. I want her to get this because I'm explaining things. But you don't know why it works. And if you know why it works, you remember. You obviously don't know how to do it because you're asking a question. Is this a true statement?
No.
Is negative 2 smaller than 4? Yeah. What if I divide by a negative 1? Cole, what happens here? This becomes 2. This becomes negative 4. And why does it switch? Because this is no longer true. So to make it true, you switch it. And that's why when you divide by a negative, that reverses. And you have to remember, you multiply or divide by a negative. Put this in your notes. Or divide, I should say. The inequality reverses. Okay? Pardon? Reverses. Now, this becomes x. What's 4 divided by negative 2?
4.
Cole, guess what? You just earned yourself an hour. Okay, what is this? No, we are not doing that. What's 4 divided by negative 2? Negative 2. And because we divided by a negative, what's this going to do? It's going to switch. You have to remember it, but if you forget, just make up a problem and say, well, what happened when I divided by a negative? The only way to keep it true was to switch that inequality. Grant, are you having issues today? Having some issues today? What are you going to do with this? Oh, we're almost done. What number divided by negative 3 is greater than 1? What do you have to do? Multiply. Now, because you're multiplying by a negative, what's going to happen to my inequality? Oh, and I forgot to graph it, didn't I? 1 times a negative 3 is a negative 3. Can't hear you. I'm multiplying. Positive times a negative is a negative. Okay, which way does that graph, Grant? Which way am I going to put the arrow? You get a 50-50 chance. What numbers? Is 0 smaller than negative 3? No. So it can't be that way. It has to go the other way. We're not doing 2 steps. I believe we're just doing 1 steps today. That was it. Okay. Well, let me stop this. So the goal is today we're going to have a worksheet to do with this. And